Okej, to myślę, że możemy zaczynać. Na początku, kim ja jestem? Nie, pierwsze pytanie. Anyone doesn't understand Polish? Okej. Wiem. Really? No Polish. Okay. So let's try in English. Okay, who am I? I'm Sebastian Malaca. I'm mostly talking about refactoring, clean code. Yeah, this is my passion. So today, because CoreDump is so special conference, I decided to talk about something totally different. I won't try to convince you why it's good to write clean code, why it's good to test your code, refactor, and so on and so on. No, today I would like to convince you and prove when it's wrong to do it, when you should choose different way, and don't refactor, don't write test, forget about design, forget about opening for extension and closing for modification. So, why is that? I'm talking with plenty of people, and developers doesn't always uses design patterns. They are not doing code review too often. Not everyone. They are not practicing TDD, pair programming, and so on and so on. And even though they are still sometimes succeeding, there is a success there. There is no problem with maintaining the code. There is no problem with developing the code. And so, do we really need it? Do we really need to read all those books? Do we really need to go to those other conferences where people are trying to convince you with words too? I still think yes, but there are some exceptions of those. Why yes? Because if you will compare the application to the bookstore, it's extremely easy to add a book here. There is no problem. You know the order. You know on which shelf it should be. In here, it's extremely hard to add anything into right place because it's extremely hard to find out the right place. To be honest, you don't even know whether it exists. But if I need to do it fast, it's extremely easier to do it in here. I'm just throwing a book and it lands there. Great, I'm going home. And it perfectly fits to this design. Here, I wouldn't do so because it will break this aesthetic. Okay, so today I will tell you about decision making. And each decision brings consequences. We've got the pros, so gains, and minuses of those. We have to live with that. And the weight of both, this is the thing that really matters. Based on those two things, pros and cons, you make a choice, whether it's okay to write a test or not. Whether I should refactor the code or I can leave it as it is. Whether I should invest my time into design or simply no. Why I'm talking about that? I don't know whether you met developers like who are extremely against all those rules, like TDD. They are in strong opposition with TDD, with strong opposition to Solid, because they really simply doesn't see any benefit of this. And they've got their arguments. On the very beginning of my career, when I start understanding these practices, I thought they are simply arrogant. After some time, I changed my way of thinking. I think this is because of us. Those who are here and trying to sell practices to you, those who writes articles, those who write books, this is our fault that those people have got arguments that it's good to not follow these rules at all. Why? Because during the conferences, when we are writing articles, we are trying. Yeah, let's be honest. This is like selling a product. Yeah, you are going to the. Before my talk, there was talk about machine learning. Really great, but it was about how cool is that. Yeah, and I'm quite interested, and I will dive into it a bit. But there is no information about problems. And to be honest, when you are facing a problem, then the real development starts. So the algorithm is like that. You are reading something, and if the speaker, author is great with communication, you start to think, yeah, this is first time in my life I found a golden solution. Great. So I'm trying to practice that. And then sooner or later, you will find an exception. This is something you cannot avoid. It doesn't matter whether it will be refactoring, whether it will be test-driven development, whether it will be anything other, you will find the exception. You will find a place where it doesn't fit. So we start to either feel bad, I did something wrong, because they told me about TDD and this is cool, it should help me, and right now I'm struggling with that and it doesn't help. To be honest, from my perspective, it shouldn't fit into here, but maybe I don't understand it. And yeah, I'm feeling a bit bad. Or I'm starting to negate the rule. Why? Because I'm quite smart, or at least I think I'm quite smart. So if it doesn't work, maybe the author, the presenter, didn't found or didn't reach this place when I am right now. This is this situation when you see as an exclusion, we are not following TDD, for example, because it doesn't work in our environment. It's not good for our application. It's not true. You just found an exception and you are propagating that. The funny stuff, because we are learning plenty of things. Practices, rules, and patterns, but also we are trying out libraries, frameworks, and tools. And the problem with the second, this is that I want to cover, is here you see the gain later. You have to wait for it. It's not like just like that, and you see the benefit of it. When you will find out that your architecture is correct, after a year, when adding new functionality, new features, doing changes will be still easy to do. With libraries, when you are looking for an exception, Stack Overflow, you are fixing it in matter of hour or two, you solve it. You see the gain. What is the gain in that case? Library, framework, generates a result. Okay, so that's a small intro. So yes, you can break everything. The thing is, when? There are some of you, I assume, who are refactoring the code, who are writing tests, who are trying to write as descriptive code as it's possible. But it's hard to become the best if you are doing so. Why? Because the cleaner code you will gonna read, the more people will just simply understand it. They don't go to you. So if you want to feel like a best in the area, don't refactor the code. Don't think about good design. Don't write tests. Why is that? Because the more you will stay at the work, in the job, in your current project, the more functionality you will deliver, the more mysteries points you will introduce, and then the people will start coming to you. Because it will be like, Sebastian, you was working about statistic. Can you tell me about something about it? Because I have to change it. I'm starting to feel important. So this is first situation when you don't have to follow the pattern. You want to feel like an important person in the room, like the smartest guy in the room. What's the pros? You may try to challenge your employee and tell him, try to fire me. They may try. What's the consequence of such an approach? Try to change your job. It will be extremely hard. Tip for you, don't be the best. Another thing, when you can forget about all the nice practices about design, clean code, Yagni, whatever, just list them all. When you are working on small projects, and that's an extremely important thing, it needs to have short life cycle. Why is that? Because everything will be in your head. You can understand each and every foo, each and every bar, bus in your code. Why? Because it took only 1 month to write it. If you are do it on your own, it really doesn't matter to invest the time in your refactoring, in the tests, because you have to spend the time on it. If this is small, short-living project, it doesn't bring any benefit. But there is a small danger, you know, all those small projects can be successful and can become a big one, huge one. Then you need to, you know, the more people, the more users, the more bugs, the more feature, the bigger feature demand, and so on and so on. So we need more people to work on it. In that case, you start thinking about refactorings and so on. So there is this tiny line between a small project and the big one, but until you will cross it, you don't have to care. Okay, now let's start with something interesting. Design. When you don't have to think about the design. POC, proof of concept. Yeah. Why we are doing proof of concept? Because sometimes I just don't know how it will gonna work. There is so many mysteries. There are so many unknowns that I'm not aware of. You really need to write it down to find them all. This is the only goal. I need to show something. There is a customer with potentially big demand. However, they still don't know whether they are interested or not. I want to deliver fast. I want to show them something. This is when we are investing in proof of concept. So what's the beauty of it? I don't need to test for that. Why I don't need the test for that? Because I'm not interested in each and every scenario. I'm just looking for those sunny scenarios. Why is that? Because sunny scenarios are the one that customers are interested in, the most interested in. Once the sunny scenarios start working, then we are talking about other potential risk. Another thing, your design can evolve during the writing. If you don't have to involve other team members, it's like I'm just starting writing a code, and that's it. I'm just creating something new. What can go wrong? With each and every POC should be thrown away. Once customer will say, yes, we are okay with that. And usually this part goes wrong. Because, yeah, we wrote it, and I'm proud. I'm always proud of my code. So how can I get rid of it? I will just write from the scratch the same thing that I already wrote. I won't tell you you have to get rid of this code, because you won't. Let's be honest. But at least keep quality high. I'm not saying about thinking about upfront design, thinking about each and every possibility. Just try to write it well. Try to start from the very top where you are using your functionality, when you are using your parties, because then it will, to the bottom, it will evolve. It is easier to keep quality of the code better. It won't be perfect because there was no design. There is no test, so there is plenty of risk there. However, this is better. Of course, if you can, just get rid of it. But POC, yeah, this is the first example where you really don't need great design. Another thing, we are introducing new thing, something that new feature, new change in the code. Of course, I can start thinking about everything, each and every possibility, each and every possible modification. And this part that I just described, where we are starting to think about everything that possibly may happen, leads to to clarifying yet another great rule, Yagni. We are so involved into trying to solve each and every possibility. We are just doing too much. So it's good for you when you are doing something new. This is not yet another feature, and I don't know, yet another report generation, because this is something you are already, you know how to solve it, but this is some new feature. Don't try to come up with each and every possibility. Try to, then there is, you are decreasing chances of over-engineering, there will be less interfaces, and you know, each and every class, each and every line of the code is additional complexity. You have to understand it. There is no other way around. You need to understand it. With increments, so this is the tip for you, with increment, you are adding new functionality. When you are writing a code in that way, yes, you are saving some time on design part. And thanks to this, slowly, but within a time, you are learning how to create, how to evolve. Your architecture will reflect somehow this evolving process, constant evolving process. What can go wrong? With less less interfaces, we will have strong dependencies. What if after a few increments I will decide this particular library is not for me? It's extremely hard to get rid of such strong dependency. So yet another tip for you, use interfaces and adapters. So introduce interface there, create an adapter over each and every external library you have. Why is that? Because it gives you a control. This adapter, this interface is your contract. This is what you're gonna need. I don't know, we need to introduce a persistency. From the day one, I don't know whether I need a MySQL, SQL, or NoSQL, or whatever else. I don't know it. But creating my application with an interfaces and some adapter in place still doesn't close me from making such a decision. Why is that? Because interface clarifies my contract. So after a while, after a few increments, I will exactly know what I need. Then I can make a decision. Okay, I'm doing a lot of searching operation. Also, okay, so maybe MySQL is quite good solution. Maybe no. Maybe I'm basing on only one object and I'm operating over it. So maybe SQL it's quite nice. With such approach, you are not making this decision in the very beginning. You are just delaying that. But thanks to this interface and the adapter, it's extremely easy to change it later. Okay, another thing, open-close principle. So yeah, less interfaces if you are not following that. Once again, lower complexity because less interfaces, less things to read. The problem, what if we will have to add yet another extension of this functionality? So let's assume that we've got something like that: report generation, PDF report factory, PDF report. Yeah, quite nice because from day one I'm creating only the PDF. Cool, awesome, nothing too complex. But what if someone will come to me and tell me, you need to add yet another report type, like XML. Quite challenging. So maybe, instead of this, we can come up with such an approach. So this is following open-close principle. Yeah? We are following it. So we are introducing interfaces and implementation. Right now we are closed for modification. If I would like to add yet another type, I don't need to change this mechanism. I'm just adding new type. Great. But what if this new feature will never happen? There will be no demand for that. I've got two interfaces. This is extremely trivial example, but within your architecture, when you are introducing interfaces for in each and every situation, because, yeah, just in case, or I just want to follow open-close principle, then you need to understand each and every interface. How to make it a little bit better? We can, on the day one, we can just get rid of this PDF from here. Why? Because day one, it's only PDF. For me, report means PDF. Simple as that. And with such an approach, it's extremely easy to go into this one because those dependencies are already established. This class are already using those. So if there will be demand for PDF from this place, I can easily go to something like that. Okay, yet another thing. Design patterns. Not only gang of 4 design patterns, those described by those guys. Each and every design pattern, rule, and so on. You don't need to put them everywhere. You don't need to convert each and every switch, each and every if-else into the pattern. If you ask me if it's possible, yes, it is possible. Each and every if, switch, for loop, while loop can be converted into design pattern. The question is, do I really need it? Sometimes it's just simpler to read it, simpler to understand it when you've got the code in one class. So how to make a decision whether I need it or not? For the day one, don't go with the design pattern until there is no demand for that, until your requirements doesn't explain you clearly and shows you really need the design pattern. If you don't need it, try out without it. Why is that? Because, to be honest, it's not so hard to introduce it when you will start, when there will be a requirement for it. What it gives you, each and every design pattern is an interface and abstraction. So yet another thing to understand, yet another thing to name, yet another thing to go through. It's quite hard. The more things you will have, the harder it will gonna get to understand it everything. What you can do to find out whether it's still okay or not? Try with code review. And I'm not talking about having a tool for that. Just ask any colleague within your team. Hey man, can you take a look at my code? Is it still clear what is going on here? Do you know the reasoning behind? Do you know the justification? Or maybe it's too blurry. Yeah, it requires some thinking, some ownership of over the code. But thanks to this, there is less things to understand. Another great thing, tests. It's extremely great to have a test. Why? Because thanks to tests, we are feeling safe. Yeah, we can go home, and if my test passes, I know that application will just be fine. Except it's not always the case. Unfortunately, even if I've got a test, sometimes it doesn't mean there is no bug. Okay, so let's challenge my one of favorite practice, test-driven development. It's great to do TDD, really. But you don't have to test everything with TDD. Just try. So if there is a functionality, and I'm introducing first test, I'm creating implementation for it. Then I'm introducing new test, and I'm creating functionality for this. Here, you don't need to TDD this guy. Why is that? And this is not, to be honest, this is not following TDD. It's like correct understanding of it. This is my entry point, and by adding more functionality into more cases into those tests, yes, this can evolve. It's not a problem to introduce new classes. Is this problem that I will have 4 parties, 3 tests, and no TDD for this? This is not an issue. Why? Because those tests drive this design. This is the essence of TDD. Not create a test before each and single, before creating each and single class or method or anything like that. No, you've got a requirement. Here you are starting. You are introducing the test, and right now you don't know what you really need. You don't know how you're gonna end. So for those 3 things, I don't need a TDD, and I still feel safe. What it gives me? First thing, I start to understand the benefits of having this. That's the first thing. Second thing, less tests. Yeah, I've got 4 classes here. Sometimes it's even better, sometimes it's less. And I don't need a test for that. Great. Less time spent on tests. Another gain, those tests will be more reliable than if I will go with TDD on those levels. Why? Because if I'm starting to TDD each and every party when I'm introducing it, unfortunately, it affects this test as well. How is that? We are using mocks because it's already tested, yeah? This is my unit. So in this place, I should have unit tests, so everything around should be mocked, faked. So I'm using this dependency here as TDD. So if you will follow TDD for each and every party, sooner or later you will end up with a test that you cannot rely on because everything will be mocked. You will start hate TDD. Why? Because here you will simply don't see any benefit of this, which is good. There is no benefit in here of using TDD. So no, you don't have to, for each and every unit, you don't have to use TDD. Where you should consider this approach when you are adding new functionality. This is my new functionality, and I still don't know how it will gonna look like. Or when you modifying existing functionality, when you are working on some tricky algorithm, tricky business rules, those are the places where you should consider TDD as a good approach. Okay, but TDD is not the end of the discussion. To be honest, we don't need to unit test everything. I don't know, are you familiar with a statistic which is called coverage? So it means we are verifying whether each and every line of our code was tested. Great. Is it great to have each and every line tested? Maybe. But if this is the only statistic that you are based on, you are starting to create tests full of mocks. Why it mocks? Because you need to write a test for everything, yeah, each and every single unit, because coverage doesn't allow me for anything except that. I need to test everything. We are automating, we are trying to simplify our work. So how to simplify writing a test? Don't create real objects, go with mocks. So we are starting to use mocks, we are mocking everything, and once again, we cannot rely on our tests, because this is mock. Mock is an assumption. I can build mock with fake assumption. It's not a problem. Until method contract will be fulfilled, I'm okay with that. But I can throw an exception from the method that doesn't throw an exception at all. I can return the value that cannot go out from the method at all. Why? Because this is mock. I've got the control over it. So what we shouldn't test? Data transfer object, don't test it. Getter, setter, setters, don't test it at all. To be honest, use a TDD in right way, don't test those guys at all. You will write less code. You will spend less time on writing tests, but thanks to those tests, you will go home and you will sleep well. Okay, and my favorite one, my beloved refactoring. You don't have to refactor everything. You don't have to refactor at all, sometimes. So let's start with no refactoring. In the past 2 months, I had a few discussions when I tried to convince people with whom I work with why they shouldn't refactor sometimes. Each and every refactoring is great, yeah? Why is that? Because I'm improving the code. It's good to improve the code, quality of the code. It's good to feel a bit better because I correct it. However, what's the problem? What if this is not used code at all? What if I'm just going, jumping from one class to another, and I'm stopping in one place, looking at it? Oh, it's bad. I will refactor it. What for? Who will ever go to this code? Why you shouldn't refactor in that moment? Because this code works. It's even if there is no tests for that, even if you are not doing code review, even if you don't follow any practice, unfortunately it was already tested on production. So don't refactor this code. Don't refactor any code you are not working with right now. When you have to modify the code, when you have to add new functionality, fix a bug, do whatever, there is one place where you are looking at, and this is your boundaries. You shouldn't go far. You shouldn't go from this circle, because refactoring is infinite loop. And unfortunately, you can refactor till the very end, even if there will be no changes at all, starting from this moment, and you will be the last person who will work on this code. This is infinite loop. You will start and you will never end. That's why refactor only those places you are working with. Nothing except that. Why? Because maybe you are the last person who will look at this code. Maybe. And the second most important, it already works, and you can break it, even if you are the smartest guy in the room. Okay, don't improve. As I said with this if-else, not each and every if-else means you need to introduce, I don't know, state, command, strategy. Not each and every switch means the same. Long method doesn't require always extraction. Sometimes it's better to leave it. How to verify that? Code review. And the most important thing, listen. Listen to other people. Listen to developers. Listen to business you are working with. Why is that? When within the code someone name a part with good name, will name only a part, this is the moment when you should extract the part of the code. Why? Because this is a concept. You really want to have this concept in this code. Why you should avoid as strongly as it possible design patterns, interfaces, and abstractions? Because this is simplicity versus complexity. It's easier to understand simpler code rather than complex. But there is something which is even more important: complexity versus knowledge. If complexity brings additional knowledge, then my choice is always knowledge. It's better if I have more business knowledge, technical information within the code, rather than keep it in one method. Don't extract it further. So if the question is simplicity over complexity, always choose simplicity. But if there is a question, complexity versus knowledge, always choose knowledge. Okay, one anti-pattern, primitive obsession anti-pattern. That means instead of creating a classes, you are always using strings in some simple types. However, sometimes obsession goes into other way around. So we are so obsessed on not going into primitive obsession that we are encapsulating each and every tiny object. In ideal world, each and every string, int, long, etc. should be wrapped in some value object. Why is that? Because thanks to this I will have more knowledge. On the other hand, if I will go into this direction, I will end up with plenty of objects, tons of them. So you need to know when to say stop. My tip for you: additional rules. So address, yeah. Each person has got an address, so I can have a field like string address, string city and string street. Cool, those two. Yes, I can have it. But also I will have a string name. There is a differences between those two. So it's okay to encapsulate and extract address as a separate. Why is that? Because not each and every street is in each and every city. For example, in Krakow, in London, we don't have a probably, I know, Kącik street is near from here. Probably there is no such a thing like that. So those are additional rules, and it's great to have a concept like address in my code, because thanks to this, when I'm looking at the object address, I know that this guy protects its invariants. On the other hand, if I'm going to my example, address and the name as a string, string as a name is still okay. Yeah, it would be great to extract a name, but it may be too far. So first, focus on those objects that really have got some additional rules. Thanks to that, you are simplifying the thing. There is not so many code there. And once again, complexity or knowledge. Okay, and few other things on the very end. And probably you will find more of them on your own. Comments are bad. And you should avoid all the comments you can. Of course, not if comments brings you a knowledge. And you doesn't have to think about updating that. Yeah, it's almost each and every comment can be removed. How is that? How? You can just rename the methods, you can extract the classes. However, if there is some sorting algorithm or some, I don't know, more performant collection, it's extremely hard to put that information into the code in other way than writing a comment. In comment, you can put a link to your evidence and so on and so on. So those are the places where I think comments are not bad. Taking technical depth, it's also not bad. When you are thinking about delivering something extremely fast, sometimes you need to. And there is a deadline, there is a bug fix, there is an emergency, or there is a customer that is waiting for you. You know there is this perfect solution, and yeah, you have an idea, you have almost everything solved in your head, but it's easier to do something you are familiar with. So yeah, for example, you are using in your application SQL, but you know it will be faster with no SQL, go with SQL. Why? Because with SQL you can prove and show sunny day scenarios. Then once you will get customers' interest, then you can think about further improvements. Another thing, there is in this great book Java Concurrency, there is a statement: premature optimization is the root of all evil. However, the most important part is not this statement, but what is after it. So yeah, most of premature optimization is the root of all evil, but there is this small percent of optimization you should invest right now, because there will be no time later. So once again, with database, if I'm creating a proof of concept for my customer, then I'm choosing not non-performant database for to present him a solution, working solution. I can use anything. However, once they will decide, I should change it. If the requirements from the very beginning proves me, it would be better to use something different. This is not premature optimization. This is optimization you should go for. Interface segregation principle, same story as with any other solid principle. Yeah, this is great. When you are working on your application, always follow interface segregation. Why? Because thanks to this, you are building the contracts. Building the contracts allows you to change your functionality. You will start thinking about new database. You will see the contracts around. This is the requirements you need to have fulfilled. But this is a different story when you are working on open source library, or a library at all, or solution that will be used within your organization. You need to think about any possible use case of it. So no, your interfaces won't be as great as you would like to have them. Okay, from my side, those are all examples. What I really would like you to take out from the talk. Everything that I try to challenge today are the tools. As each and every tool, you can use it in good way or in inappropriate place. You don't have to feel bad when you are not following principle, when you are not you are breaking principle, you are not using some practice. Just ask yourself whether your arguments, your justification make sense. Maybe in this specific context, it's really better for you to not follow it. There are always consequences of your behavior, and try to find those, because thanks to when you are not following something, you already know the gain. You already know why you are trying to avoid it. Try to find out the consequences of it. Then compare and make your decision. Okay, thank you very much.